this lesson we want to look at hello, welcome to this lesson. So in this lesson we want to look at equality of surds. At the end of this lesson you should be in this lesson we want to discuss equality of surds. At the end of this lesson you should be able to state when two surds are equal, and then you should be able to use it to simplify expressions. So equality of surd is not a new thing that you've not seen before. It's just like simplifying surd and making it equal to a certain letter, and then after you've gotten the answer you can now equate the letters to the values you have and find the value of the letters. So equality of surd, when two statements are equal, they have the same value. Okay, so of course if we say 2a, okay, if you say 2a equal to 4, if you solve this equation you have dividing both sides by 2, you have a equals to 2. So what makes this 2a to be equals to 4 is because a equals to 2. So also it can happen in surd. I can say 2x equals to 2 root 2. Okay, what makes this statement equal? If we cancel what is common, then we have x equals to 2 root 2. So what makes 2x to be equal to 2 root 2 is because x equals to 2 root 2. And this is how we can use the principle of equality of surd to solve equation. So it's also a way of simplifying equations involving surd. So let's just look at quick example. It's not a new thing that we've not seen before. It's just another approach. Okay, calculate the following. So for a, we're going to let a plus b root c equal to the statement we have in bracket 6 plus root 3 close bracket 5 minus 2 root 3. Okay, so we're going to solve this as we're going to open the parentheses and then we equate to what we have on the left hand side. Okay, so let's open the parentheses. 6 times 5, that will be 30. 6 times 2, that will be 18 root 3, and then we have 3 times 5, that will be 15. Okay, root 3, and then 3 times 2 is 6, and root 3 times root 3, that will be 3. Okay, so we can collect like term here to be 30. 6 times 3 is 18, so 30 minus 18, minus 18 plus 15, we have minus 3 root 3. Okay, so that's what we are going to have there. Okay, alright, so that will be minus 3 root 3. We have 6 times 2. Okay, so this expression here is 6 times 2. Okay, let me just correct that. So 6 times 2, that should be 12. Okay, so 6 times 2 is 12. So minus 12 plus that, we have plus 3. And 30 minus 18, that will be 12 plus 3 root 3. So if we compare, we have a plus b root c equals to 12 plus 3 root 3. So therefore a equals to 12, b equals to 3, and c equals to 3. So we've equate this out to an unknown expression a plus b root c, and we've been able to find the value of what the expressions stand for. Okay, so that's how to simplify equality of surd. So let's take the second one and see what we have there. For b, so we also go the same way. A plus b root c equals to 6 plus 3 root 3 into 6 minus 3 root 3. Okay, so if you look at this one, it seems they are conjugate of each other, so we just apply difference of 2 squared. 6 squared minus 3 root 3 squared. Okay, so 6 squared is 36 minus 3 squared is 9, multiplied by root 3 squared, which will be 3. So 36 minus 18, and then we have the 36 minus that 9 times 3 should be 27. Okay, 9 times 3 should be 27. So 36 minus 27, and then we have the answer to be equal to 9. So therefore if we compare here, a plus b with C equals to 9. So this implies that A equals to 9, B equals to 0, C equals to 0. So this result is special because those surds that we just multiply, they are conjugates of each other. So that happens whenever you are multiplying a surd by its conjugate. So for C, we're going to try out C and we mark together, okay? So as usual, let A plus B with C equals to 5 plus 2 root 3 parenthesis 5 minus 2 root 3. Okay, so solve this equation and when you are done, we'll solve together. Okay, expanding this expression, we simply have this 5 times 5, which is 25, plus we use difference of 2 squared because they are conjugate of each other, minus 4 times 3. So that will be 25 minus 12, which is 13. So therefore here, if we compare, we have A equals to 13, B equals to 0, C equals to 0. So because they are conjugates, we do not have B and C, we only have A. Example 2. Let's take the last example, example 2. If A plus B root 3 equal to 4 minus root 3 squared all over 2 plus root 3, or find A and B. Find A and B. So let's try to simplify. So we write out the equation A plus B root 3 equals to 4 minus square root of 3 squared all over 2 plus root 3. So if we expand the numerator, we have 4 squared, that will be 16, minus 2 times 4, that will be minus 8 root 3, the difference of 2 squared, plus 3 all over 2 plus root 3. Okay, so if we collect like terms in the numerator, 16 plus 3, that will be 19 minus 8 root 3 all over 2 plus root 3. So we can't leave this like this, we have to rationalize the denominator. So we multiply by the conjugate of the denominator, which is 2 minus root 3. Then if we expand, we have 19 minus 8 root 3 into 2 minus root 3 all over 2 plus root 3 into 2 minus root 3. Okay, and then we have 19 times 2, that will be 38. Okay, 19 minus 19 root 3 minus 2 times 8, that's 16 root 3. Minus times minus, that's plus, and 8 times root 3 times root 3, we have 3 all over 2 times 2, that will be 4, minus root 3 times 3, that will be 3. So we have 38 plus 24, because 8 times 3 is 24, minus 19 minus 16. Then we have minus 35 root 3 all over 4 minus 3, which is 1. So collecting like term, we have 38 plus 24, that will be 62. Okay, so we already have that here, 62 minus 35 root 3. So therefore, if you compare with A plus B root 3, you have A equals to 62, B equals to 35. So this is how you apply equality of surds to simplify problems. See you in the next lesson. Bye.